All right, let's do one more. It's going to actually be an initial value problem. So this is number 28 in the section. Again, it asks us for the first 4 non-zero terms about x equals 0. And I'm probably just going to do the first 3. Okay, and the equation is y double prime plus x minus 2 y prime minus y equals 0. Okay, and we get y of 0 is -1. Oh, y prime of 0 equals 0. Oh, I don't like that. Reason I don't like that, oh, I guess we're going to just do it. All right. I don't like it because it gets rid of half of it. Okay? I mean, we still need to do a lot of this stuff, but it sort of gets rid of half of the work. So let's go ahead and start with our equation. So our assumption, y equals the sum, n goes from 0 to infinity, a sub n, x to the n. Okay, a sub 0 is -1, and a sub 1 is 0. Okay, because you take y prime, that's going to be sum, n goes from 0 to infinity, n, a sub n, x to the n minus 1. Of course, the n equals 0 term is 0. So the first term, the one that's going to give us what happens at 0, is given by n equals 1. Okay? Y double prime is, of course, the sum. N goes from 0 to infinity. N times n minus 1, a sub n, x to the n minus 2. Okay. Let me move this a little bit around. And now we're going to put it into the differential equation. Okay, so the dE is going to be the sum. N goes from 0 to infinity. N times n minus 1, a sub n, x to the n minus 2, plus x minus 2 times y prime. So n a sub n, x to the n minus 1, minus a sub n, or I'm sorry, y sub n, or y, a sub n, x to the n. That should equal 0. Okay? Now let's go ahead and put the combination together. So the x here is going to multiply on here, so we're going to get now this one I can do probably a little bit better. I'm a little bit easier because not so much is changing. So this one, let's just write it immediately as an x to the n. Okay, so if I write this as x to the n, okay, that means my first term should be here. That's going to be when n equals 2, right? So I'm going to need n plus 2, n plus 1, a sub n plus 2, x to the n. all I'm doing, remember, is I'm just making sure I match up the first term, okay? So when first term here, remember, when n equals 0, it's 0. When n equals 1, it's 0. So the first term doesn't come out until n equals 2. Okay, so that means 2 and 1. So that's where I'm getting the n plus 1, n plus 2, and n plus 1. The first term is a sub 2. So that's where they get a sub n minus plus 2 there. Okay, plus. Now I'm going to do n a sub n x to the n. That's this x multiplying all that. Okay, minus 2n a sub n x to the n minus 1. I'm going to need to shift that. Minus a sub n x to the n equals 0. Okay, so now let's shift this term. Sorry, I'm going to do this instead. I mean, if you can't do this, then why even have this capability, right? Because all I'm really doing, I'm just going to shift this term. Okay, so I'm shifting that term. When n equals 0, this is 0. Okay, so I need the first term to be the n equals 1 term. Okay, so I'm going to have x to the n, but now instead of the n, it's going to be negative 2 times n plus 1, a sub n plus 1. Let's move this a little bit over. X to the n. Okay, so let's just keep in mind what I did there. I said, all right, when n equals 0, this is 0. It doesn't even come into play. First time I really do anything is when n equals 1. I'm going to get x to the 0. That's fine. Okay. This term has to be 1 the first time it's non-zero. So I'm going to change that, shift that to n plus 1. That one's going to need to be a sub 1 the first time that it's non-zero. That's the a sub n plus 1. Okay. So since they all have the matching x to the n, I can now write the recursion relation. I'm going to isolate a sub n plus 2. That's what I need to solve for. A sub n plus 2 equals, well, there's the 1 over n plus 2, n plus 1, times. I'm going to need 2 n plus 1. Nope, I was right. 2 n plus 1, a sub n plus 1. That's this term when I move it over to the other side. Okay. That term's going to become plus, that term's going to become minus, so it's going to be plus 1 minus n a sub n. Just making sure. Okay. Now, let me just simplify it a little bit. A sub n plus 2 equals 2 over n plus 2, a sub n plus 1, plus 1 minus n. Let me write this as minus n minus 1, n plus 2, n minus 1, a sub n. Looks a little better that way. Okay, so we know from up here, from our initial conditions. A sub 0 is -1, a sub 1 is 0. Okay. Okay, so now, a sub 2. That is, of course, n equals 0 again. That's the n equals 0 case. So we're going to take a sub 2 equals 2 over 2, so 1. A sub 1 minus -1 over, this was n plus 1. I don't know why it became -1. I mean, I know why, because my handwriting stinks, but oh well. So that's -1 over 2 times 1, a sub 0. A sub 1 is 0. A sub 0 is -1, so that's going to be 1, 2, 3 minuses, minus 1/2. Okay. A sub 3. A sub 3, that's of course n equals 1, so that's going to be 2 over 3 a sub 2 minus 0, right, because of that n minus 1, a sub 1. Not that it matters because a sub 1 is 0 anyways. So a sub 3 is going to be -1/3. Because remember, a sub 2 is -1/2. Okay, let's do a sub 4. That's n equals 2. So a sub 4 is 2 4, so 1/2 a sub 3 minus 1 4 over 12 a sub 2. Well, I know a sub 3 and I know a sub 2. So I'm going to get what, -1/6 plus 1 over 24, which is -3 over 24, -1/8. Okay, so our solution is, of course, to four terms, right? But it's going to be -1 minus 1/2 x squared minus 1/3 x cubed minus 1/8 x to the 4th. Okay, all right. I'll see you all in the next set of videos.